Perfect. Um, so good morning. Good morning. Today we have just one last concept to cover. I would like to mention that before we round up lesson 5, and we will go through one of the labs, one of your Xi labs together today, and we will, call it a day and enjoy the spring break. So, before we start, any question from the um other concepts, previous concepts we have learned in this class, we have discussed, any question, any concerns, any clarification you would like to make? You understand how the while loops work, how to do while loops work, and now we the last our last discussion on Tuesday, we talked about the for loops. So, any question on any of these loops and how they work, the 3 basic requirements for any of the loops we are writing, you know, our control variable. Very, very important because we have to initialize our control variable, which is going to do what? Our control variable will involve with the second condition. So our control variable will be checked against the condition, which is the second requirement for any loop we're writing. So, and after that, we need to update. We need to modify the control variable in order not to have an infinite loop, you know. So this is a way to say, hey, I think I've gotten to where you need to stop. The condition has been met, so you need to break out of the loop. So that's what we have for the our modifier, or what I call it, an update. Like we're updating, we are modifying the control variable. Any questions on any of those concepts, you can differentiate them, you know, the different recommendation when you should use what, we discussed that last week. No, on Tuesday, we discussed that on Tuesday, that follow is always recommended when you know the exact, you're sure the exact number of loops. Like, I have to print my name 10 times. I am sure I am only printing my name 10 times, then good. Follow is the most advisable loop to use in that kind of scenario. When you're sure, you're certain, that's the word, the exact number of loops, the exact number of iteration, the exact number of iteration. So when we when we don't know the number of iteration, we are not sure how many times it is recommended we use our while loop. No, while loop is always recommended when we don't know the number of iteration within the specific loop. And the do while is just the opposite of the while loop. So, the while loop we run at least 0 or more times. While the do while loop we execute at least one. At least one. So the do while loop is always recommended when the loop must be executed at least once. Either it is false, either it is true. So the loop must execute once, and you can differentiate between the pre and the post. We were talking about the pre-test and the protest. Why is the while loop called pre? Because the condition and the control variable is actually checked before execution of the loop. So the condition and the control variable is tested. You're testing it. Is it meeting the condition? Is the condition and the control variable relating? Is it true or false? And if it is true, what happens for while loop? It jumps into the loops and it start executing. And that's why we call it the pre. However, in the do while, which is the post, what happened is that the condition and the control variable involve after the first iteration. So it's always checking the control variable and the condition after one iteration. So it has to be at least one iteration will be executed before the condition and the control variable is being checked. Any question? Do you understand? Like, that's just a short summary, a brief summary of what the loops is all about. Either it's a for loop, while loop, or the do while loop. You can differentiate them, and when you see them in the exam, can we're talking about the while loop here. And for while loop is 0 or more times. So it means the while loop may not execute at all. And do I? Of course, it has to execute at least once. So you're sure of the different syntax where the three requirements are placed, are positioned when we're writing any of these loops. For for loop is always on a single line. You initialize, you also write your condition, and you provide the updates for the control variable. So you're initializing your control variable with a semicolon. You are checking, you're putting the condition, the Boolean expression, also in a semicolon. However, the modifier, when you're updating, must not be followed by a semicolon. Why? This will lead to a what? A logic error. So when you see that kind of, questions in your exam, you do not have to even check the options, this is going to be an error. So we want you to we want you to be, to understand this concept and to be able to use it. And even outside the object-oriented programming language, outside this course as a whole. So today's class, I would like to introduce the concept of nested loops. Nested loop. What does nested loop mean? Simple. Like you have different, description, example in your lesson, in your class notes, I mean your textbook, your Zybox. Nested loops are loops inside, embedded in another loop. So this is a loop within another loop. So this loop are always embedded inside another loop, and this kind of loop makes our program to be complicated, to be complex. Now we're talking about increasing the complexity of our code. So that's what a nested loop does to our program. And it's just, the simple description is always loop within a loop. So you are looping within a specific loop. And with that, we have what we call the inner loop and the outer loop. And we will see an example to better describe which one is an inner loop, which one is an outer loop. On our course canvas, am I sharing? Oh God, oh my God, I'm not sharing my screen yet. Okay, I am sharing. Okay, so let's go to our course canvas page, and I pasted this code in the announcements. So you have this code on the announcements page. Can you copy and paste this code in any of the IDEs you're comfortable to work with? And let's trace the code together just to illustrate how nested loop works. Thumbs up if you have your IDEs set up, it's open, and you're ready to copy and paste. I'll just give a few minutes. Yeah, I was ready. So let's see who is ready. Who is also ready? Leg. Oh, thank you. I guess everybody's ready now. So copy and just paste. Copy and paste this code. Just copy and paste this code on your programming environment, anyone you're using. So of course, The name of this program is the nested loop one. It's just an illustration of how nested loop works. And we have declared, you can see two variables. We actually initialize and declare two variables, and that's num1 and num2. And you can see this is a for loop. And within the for loop, we have another for loop. Just an example. It could be more complex than this. We can have multiple. We can have y inside of a for inside of a while loop. We can have them many. Like we can have three more for loops within one for loop. So it could be more complex than this, depending on the problem at hand we are trying to solve, on the problem we are trying to provide a solution to. So you can see this is a for loop here. And what have we used here? What have we used? Which of the variable is controlling this for loop? I can see it. Num2 is controlling the outer. So this is the outer. That's the one. Hosting another for loop. So the outer one, hosting, is always the out, is always called the outer loop. The loop hosting is always called the outer loop. And the one within the hosting loop is called the inner loop. So I have this comment just for description. And you can see num1 is controlling the inner loop. So let me ask a simple question. Which of these variable do you think will execute first? And it will change the quickest. No, this is two questions. Which one we execute first? And which will change the quickest over time, over iteration? Any opinion? So if we check, you can see, of course, the first loop will be executing first. And what happens? Because until this is true, before the compiler moves to the inner loop. Do you understand me? So let's say num1 and num2 here is equals to 0. We have initialized this control variable num2 as 0. And we're telling the condition, if num2 is less than or equals to 5, is 0 less than or equal to 5? No. Then we have our modifier. Because it is true, what happens? It goes into the next line of code. And the next line of code here is what? Another loop within a loop. So the next line is our nested loop. That's the loop within a loop. So, and it's going to check again. Oh, num1 equals to 0 as well. Okay, if num1 is less than or equals to 5, is 0 less than or equals to 5? Yes. So what happens? We're telling this is what you should do if this condition and this control variable is true. So we're telling system print out, we're telling it to print num2, the value of num2 that we have here, which is 0. Can you remember the value of num2 is 0 because that's the first iteration. Num2 the outer loop gets to execute only when the inner loop is false. Again, after the first execution, the second execution is until the inner loop is false. So what happens? It says, oh, num2 here is 0 and num1 is what? Also 0 at the first iteration. And that's why you can see the output. We have 0, 0 as the first iteration. However, that has not ended. It won't break out of the loop yet, of the inner loop yet. it will go back again because of we have updated. We have updated. Now the value of num1, now the value of num1 is 1. So it checks again. Is 1 less than or equals to 5? Yes. So what happens? It prints again. What does it print now? The value of num2 and the new value of num1. So the value of num2 is still 0 because we have not break out of the inner loop. We are still within the inner loop. And it prints 0. And the value of num1 now has changed because of what? Because of our increments, our increment operator, which is our modifier, what we're using to modify our control variable. And it prints what? What does it print? 1. It's still true. So what happens? I still go back to the inner loop again and check. Now we have 2. Is 2 less than or equals to 5? True. So it goes back to this printing statement and now prints the value of num2, which is still 0, and the new value of num1, which is what? 3. Which is 2 rather. And now with our modifier, the new value of num1 is now is 3 less than or equals to 5. True. Until we have 6. Until our increment gets to 6 and the num1 is initialized as 6. Has been updated to 6 and it now check is 6 less than or equals to 5. No, that's false. So it goes back to the outer loop. Now it is false, so it goes back to the outer loop and say, oh, now the outer loop is now 1. Don't forget how our increment operator works. So it checks again. Is 1 less than or equals to 5? Yes, 1 is less than 5. So it goes back to the inner loop. And what happens in the inner loop now? It checks again. Num1 is 0, and all over again. And that's how we have the input and the outputs. It checks until each of the loop return false before it breaks out of that specific loop. Until both the inner loop and the outer loop is false. However, the inner loop will change quickly. It will be quicker than the outer loop. So the iteration within the inner loop will be faster, unlike the outer loop. Do you understand? Any question? The outer loop, this outer loop, iterate slowly because until our nested loop, which is the inner loop, is false before the compiler goes back to the outer loop. Any question? In terms of if you understand how the nested, how a nested loop operates, how does it work? I guess nobody understands this. I'm not seeing any thumbs up. It's a very small class today. Okay, thank you. Only two people understand. Let me know if you have any question. Nested loop. The concept of nested loop, loops within a loop. That's loop. It could be more than one, but it's always loop inside embedded in another loop. It could be loops inside embedded in another loop. And it depends. It depends on the problem at hand. And it makes our program, it makes our programs to be more complex. It is very, very important. And you have different other examples in your Zyrox. can see nested loops are loops that appear in the body of another loop. The nested loops are commonly referred as inner loop and outer loop. The outer loop is always the one hosting another loop. So it's just a brief description of how nested loop operates and how they work. So you have several examples to follow in your textbooks and learn more about how nested loops operate. That being said, any question? Any question before we proceed to the last thing we have to do for the specific lesson, in which is our labs. So let's work on the 5.25. Countdown until matching digits. Let's work on the countdown until matching digits assignments. So what are we to do here? The first thing we have to do, don't forget the life cycle of our program. We have to do what? The problem solving, analyzing the problem. We have to understand the problem before implementation of the code. So how do we understand the problem? Of course, we have to read the problem. We have to read it. We have to analyze it. We have to, specify requirements. What are the needed requirements to solve the specific problem? So this specific problem wants us to write a program that takes an integer. First requirement, that's first specification here. We need integer data type. That takes an integer that range, the range is from 11 to 99. Any integer before 11, I mean 10, 9, 8, will not be accepted, will not be taken. Any integer after 99, I mean 100, 200, 300, is invalid for this specific problem. So you can see we have two main specification here already. And the output of the program is a countdown starting from the input integer until an integer where both the digits are identical. Until we get to an integer where both digits are identical. So if you put, if we have 12, so we have 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, until 22, until an integer where both digits are identical. So the example we have here is probably we're putting in 93. So we have, we need to count down, not count up, I'm sorry. We need to count down, sorry. So the example for 12 was wrong because we need to count down. So we need to count down. So we're counting down, not counting up. So for instance, we have the 93. And to count down, we have 93, 92, 91, 90, 89, until 88, where both digital words are identical. So that's what we want to do, but it is not stopping there. We want to read the instruction folder. Don't forget, we already have three specifications here. It's an integer, should be between 11 and 99, and it should count down until we have an integer with the same digits. Both digits are the same, identical digits. So, but there are other specifications down here that we have. For coding simplicity, follow each output line with a space, Even the last one, there should be space. So we'll see how we write that. And use a while loop. Can you see? Can you see the other instruction? We should use what? A while loop. We should use a while loop. Compare the integer. Do not write a large if else. for all possible same digits. Don't say if 11, don't just list in 11, 22, 33, 44, 55, 66, 77, 88, 99. You know, that will make it will be so messy. And someone else will pick up our code and it will be so confusing. Like, what has been done here? It's not even efficient. It's not the most efficient way to write our code. It's just like you're printing hello 100 times. When you have the for loop, that will do that for you with just one line of code instead of having to write 100 lines of print statements. So let's do this. So I'm gonna copy, I already saved this. I'm gonna copy and we will trace the code. So let me copy and we will trace the code. So how do I, can you see my screen? My screen is still visible. Thumbs up if you can see my screen is still visible. Thank you. So please follow along. I am not going to provide this code I'm not going to provide this code on the Canvas page. I am not going to make announcement of this code. So I want you to write along with me for the purpose of the people in this class. That's the purpose of this. So I'm going to name it a lab program. I want to be sure there's in Zyvox are there whole lab programs here. So lab program, what's the name? So to open, so Control V. So let's trace the code. However, I want us to trace and I also want to see the instruction here. So we have it side by side. So let's trace the code and be sure we have done the right thing. So write a program that takes in an integer. That's the first requirement. That's the first specification we have here. That takes in, that is, you are requesting the user to provide the value, that integer, right? Are we on the same level? Is that your understanding about that takes in an integer? Yes or no? Thumbs up if I'm correct. Do you think I'm correct? Do you think that's correct? That takes in. Thumbs up if that's correct. That takes in an integer. Taking in an integer means you're requesting, you're telling the users to provide that value for you, for you. We are asking user, please give me an integer value. And when we want to do that, don't forget our scanner class. Our scanner class is very important. That class helps us to grab value from our keyboard, grab value from our users. And that's why we have to import, that's why we have to import. What are we importing? We're importing the scanner class. So it's like import Java, and this we are accessing the scanner class. We're opening our main method here. And sorry, this is the end of main. End of class. We'll keep writing comments in between. And can you remember something about the scanner class? We discussed that in our previous lessons. The scanner class is an instance method. And for an instance method to use an instance method, we need to create an object. Don't forget, we talked about the static method and the instance method. And here, the scanner class is an example of an instance method. So we need to create an object. So the name of the object created here is called SCNR. That's the abbreviation for scanner, kind of, for me. And this is the method we are using. This is the method that tells the compiler this information will be grabbed from the keyboard, And we need to declare. So we're declaring our variable here. And this is the variable, this is the container. This is the container that will hold the value the user is generating. And we're saying, don't forget, the specification in our question, in our problem is that it has to be an integer. So we say int num. Num, you could name it, it's user defined. That's the variable name. So num here, and it's calling this method. And what this method does is to grab whatever the user has imputed in the keyboard. And what is the next thing? It has to take an integer that range from 11 to 99 inclusive. So it has to be 11 and 99. So what should we do? What is it saying? So we're saying if the number the user generated is less than 11, or what number the value the user gives us is greater than 99. So if it is less than 11 or is greater than 99, then we are telling the computer to print out input must be between 11 and 99. Have we solved this order, have we, provide solution to the order specification? Yes. First, it has to be an integer to grab from the user. Second, it has to range. So, and don't forget, our whole statement here is saying at least one of this must be true. So it's either 11 or 99, just print. It has to be between 11 and 99. So else, that is, if the value the user has provided us is within 11 and 99, what will happen? And we're saying we should use, don't forget the other requirement, the other specification we have in the problem is that we should use a while loop. We should use a while loop. And we say, okay, so what happens? What numbers? So how do we get to tell the compiler to start countdown when the number, to stop the countdown at two identical digits? That's what we want to do here. And we're saying y number divided by 10. If the number is divided by 10, so here we're trying to calculate the tens, we're trying to calculate if the number is divisible by 10, and what is the remainder? We're also and not. So we're saying if whatever value the user has provided us divided by 10 not equals. So not equals, don't forget our relational operators here. And we're saying if it's not equals to when the number is divisible, this is our modulus. Don't forget this operators here. That's the remainder. You're saying the remainder of 10. So we say the system should print the number, and this is just telling that there should be space in between the number. And this will even give the last. Don't forget we have the specification that end with a and within your line we have where we said there was a specification where it says we should even have. So there was a specific, for each output number by a space, even the last one. So we have accommodated this here, that there should be space in between them and even the last number. And don't forget the three requirements for while loops. First, we need to initialize the value. We already initialize here. Number one, taking the whatever the user provide, whatever values the user provide. The second requirement for our while loop is always the conditioner. And this is the condition that we'll be checking. This is the condition that we'll be checking, that will be involving with what? With our control variable. And the last but not the least of the requirements is to modify that control variable. So we are counting down. So we used our decrements operators. So here, what does this mean? It means that our loop will continue while two digits are different. So let's do it. Let's do this and see what the output. So we're telling if this condition, so just go out and print. If this condition is not met, so just print the number. And the last line of code here, that's the one I just read, and with a new line. So, and with a new line. So we're saying in a new line, and we're not putting anything because it's just a new line we want to end with. Any question on this? And this is the end of the loop entirely. End of the loop. So let's run it and see what we have. So I wanted to have the same output. So let's put 93 and see what happens. You can see what happened. Let's trace this code. So let's come to a while loop and see what has happened, because for this, it means this line of code has been executed. So let's say we're saying num, we've provided 93. 93 divided by 10, 9. Don't forget it's an integer. It's not 9.3. It's an integer. So what happens? Don't forget our casting. Implicit, explicit casting. Type narrowing, type widening. So it narrows to fit in an integer. And what have we tell? So that's 9. That's the way the Java, you don't have to put a specific command because we're narrowing, we're not widening. So it's like, 9. So 93 divided, divisible, modulus 10. That's 9. And what's the remainder? Which is the modulus 3. So they are not identical. So they're not identical. So why not? So it goes here, and because we're counting down, we're counting down. So it's a decrement modifying, updating of the control variable. So we now have 92. 92 divided by 10, 9. Yeah. It's an integer. It's not going to say 9.2. And we say, 92 modulus 10. That's 2. So they are not identical. 9 and 2 are not identical. No. So it goes again and say, now we have 91 as the variable, as a control variable, as the updated variable. So 91 divided by 10, 9. Java program will exclude the dot 1, the point 1 after it, and say 91 modulus 10. So it's 9 and 1 are not identical, two different things. So what happens again? The control variable is now what? 90. 90 divided by 10. Until we have two identical, which is 88. And it stops. That's the instruction we give. Any question on this? So I'm going to rerun it, and let's put, because we also have 11 here. Let's see. What happens here? What do you think happens? This is a while loop. This is 11. 11 divided by 10. 11, 1, you can see 11 is a what? It's an identical number. So what happens? It doesn't execute at all. And it just goes to this line of code outside. This is not the end of the loop. I'm sorry. This is the end of the loop. So it goes outside the loop and just prints and just execute this. And just print the number itself, the 11 the user has generated, because it is identical. So let's rerun it and have, let me put, for instance, 9 here. So you can see, because it doesn't even execute, it doesn't even get to the lobe, to the bottom. It's here. We already said that's the if statement we're having. So then if this is this, if it's any of this is not made, just print input must be between 11. So the input is 9. That is outside. That is outside the valid number. So the input is not even valid, because the number that will take this loop to execute must be between 11 and 99. Any question? Thumbs up if you understand. There's any question, any query, any clarification? Is the code running perfectly at your hand as well? So exactly, I wanted us to end this class at 10. So I'll stop the recording now.